Interest rates, Part 1. Effective rates of compound interest. So far, we have only encountered rates of compound interest expressed as an annual or yearly rate. For example, 6% per annum, giving I equal to 0.06. In the world of finance, there are many other ways of expressing the rate of compound interest. To begin with, the interest period does not have to be a year. It could be 6 months, 3 months, 1 month, etc. For example, we could have an interest rate of 1% per month or 3% every 6 months. An interest rate of 1% per month means that 1% of the principal at the beginning of a month is added by way of interest at the end of that month. The time interval at which interest is added to the principal and converted into principal is called the compounding period. As we will see later, the interest period and the compounding period do not have to be the same. But when they are the same, the interest rate is called an effective rate of compound interest. When we have an effective rate of interest I, whatever the compounding period, we are entitled to use all the compound interest formulae from the last section. For example, P is equal to A times 1 plus I to the power T, and P is equal to A divided by 1 plus I to the power T, where I is the effective rate of compound interest for the compounding period, and T is the number of compounding periods. For many practical questions, we need to be able to convert between different effective rates of compound interest. The two most important are converting from an effective annual rate to an effective monthly rate, and converting from an effective monthly rate to an effective annual rate. The following example illustrates both conversions. Part 1. Find the monthly rate of compound interest equivalent to an annual rate of 7%. Give your answer as a percentage, correct to 4 decimal places. So when we see the word equivalent and compound interest, we want to think of the compound interest formula. This is on page 30 of the formula tables, and it is P equals A times 1 plus I to the power T. We're going to let the I be the equivalent monthly rate of interest. We're going to let P be the value of the sum, A, at the end of 1 year. So P is the value of the sum A at the end of 1 year. This should be the same whether we use the annual rate or the equivalent monthly rate. So the idea here is that the P will remain the same. Whether you're using the annual rate or the monthly rate, you still end up with the same amount if they are equivalent. So by the annual rate, so using our compound interest formula, we have P equals A times 1 plus 0.07. And I guess technically you can say this is to the power of 1, but we don't need to have it written in here. So the 0.07 came from the question, 7%. We know that the annual rate is 7%. We're trying to find the monthly rate. For the monthly rate, there are 12 compounding periods because there's 12 months in a year. Thus, when we substitute into our compound interest formula, we have P equals A times 1 plus I to the power 12. So we don't know what the I is. That's what we're trying to find out. Notice that they both start with P equals. So because they are both equal to P, we can just let them equal each other. So we end up with A times 1 plus I to the power 12, which we got from up here, is equal to A times 1.07, which we got from up here. And I guess technically this is to the power 1. We can cancel out the A's. This is an A on either side. So we're left with 1 plus I to the power 12 is equal to 1.07. The 12, the power 12, comes over the equal sign and becomes the power of a 12th. Or that can be written as the 12th root of 1.07, gives us the same thing. So 1.07 to the power 12th, or the 12th root of 1.07, is 1.00565445. We bring the 1 over the equal sign, it becomes minus 1, so we're left with I is equal to 0.00565445, and giving a rate of 0.5654%, correct to 4 decimal places, which is what we were asked for in the question. Percentage correct to 4 decimal places. Note that this is less than 1/12 of 7%, which would actually be 0.5833%. So in case you wanted to work it out, that you just basically work out the yearly rate and you get 1/12 of that, it's not the same thing. So you have to follow this process to get the right answer. Part 2. Find the annual rate of compound interest equivalent to a monthly rate of 1%. Give your answer as a percentage, correct to 4 decimal places. So this is basically the same question as part 1, just the other way around. This time we're looking for the annual rate, but we're given the monthly rate. So same steps, again we use our compound interest formula. Let I be the equivalent annual rate, then by the same reasoning as in part 1. So we have our annual rate is P equals A times 1 plus I. Technically, again, you could say it's to the power of 1. We don't know what the I is, that's what we're trying to find out. The monthly rate, again, subbing into the compound interest formula, P equals A times 1 plus 0.01 to the power of 12. 0.01 is 1%, we got that in the question, and it's to the power of 12 because there's 12 months in a year. Again, notice that they both have P at the start, they're both equal to P, so we let them equal each other. So we have A times 1 plus I down here is equal to A times 1 plus 0.01 to the power of 12. We have A times 1 plus 0.01 to the power of 12. Next we cancel out the A's. So we have 1 plus I on the left of the equal sign, and 1 plus 0.01 to the power of 12 on the right of the equal sign. 1 plus 0.01 is 1.01, that's still to the power of 12. And 1.01 to the power of 12 is 1.12682503. We bring the 1 over the equal sign, it becomes minus 1. So we're left with 0.12685203. So here we have our interest rate as a decimal, but remember we want a percentage to 4 decimal places. So it gives us a rate of 12.6825%, correct to 4 decimal places. And again, it's very important to note that this is more than just doing 12 times 1%, which would give us 12%. So just because you have the monthly rate doesn't mean you times by 12 to get the annual rate. It's very important that you follow these steps. From example 1, we can now state a formula for converting between effective interest rates with different compounding periods. So converting between annual and monthly interest rates. If I is an annual rate of compound interest, then the equivalent monthly rate is 1 plus I to the power of a 12th minus 1. And if I is a monthly rate of compound interest, then the equivalent annual rate is 1 plus I to the power of 12 minus 1. Note that to reduce the compounding period, example from yearly to monthly, and go to a smaller rate, the index is a 12th. While to increase the compounding period, for example from monthly to yearly, and go to a higher rate, the index is 12. Conversions between other compounding periods can be handled in the same way. So for example, if you were looking for weekly, it would be 1 over 52 and 52. If you were looking for daily, it would be 1 over 365 and 365 and so on. Although it is handy to use these, I would suggest doing out the long method that we did in the last couple of examples instead of just learning off these formulas. These formulas are not in the formula book. The compound interest formula is, but these formulas are not. So going forward for the rest of the examples I will be using the longer method. I won't be literally just subbing into a formula, but I will end up coming to this as I'm working through the question. And here's another example, and this time it is actually weekly. So we have a power of 52. So this is the formula down here. This is where you could, if you wanted to, jump straight to the formula. But again, I like to do it out the longer way just to see what's going on. A moneylender advertises a weekly compound interest rate of 1%. Taking a year to be 52 weeks, find the equivalent annual rate of compound interest. Give your answer as a percentage, correct to 2 decimal places. So again, because the question has mentioned equivalent and compound interest, we know we can use our compound interest formula, which is on page 30 of the formula book. So we're going to let I be the equivalent annual rate of compound interest. And as there are 52 weeks, there are 52 compounding periods in a year. So the annual rate is going to be P equals A times 1 plus I. Because remember, we're looking for the interest, the annual rate of interest. The weekly rate is going to be P equals A times 1 plus 0.01 to the power of 52. So we've swapped the I for 0.01, which is 1%, and the T for 52. There's 52 weeks in the year. So notice again that they're both equal to P, so we can let them equal each other. So we have A times 1 plus I on the left is equal to A times 1 plus 0.01 to the power of 52 on the right of the equal sign. We can cancel out the A's. So we have 1 plus I is equal to 1 plus 0.01 to the power of 52. In the next step, the 1 has just been brought over the equal sign, so we have minus 1. 1 plus 0.01 is 1.01. That's to the power of 52, which gives us 1.677688921. And then subtracting the 1, we end up with 0.677688921. So this is the interest as a decimal. We want it as a percentage to 2 decimal places. So we get an interest rate of 67.77%, correct to 2 decimal places.